All right, integrated one, we are going to be doing something called two-way frequency tables. Right now, y'all are just being introduced to statistics. And so we're not doing a huge deep dive into this. We're just doing the mechanics on this, y'all. So we're going to basically look at a couple of words that matter. And we're going to look at this. So y'all know how I feel about some of these definitions in math. Like I could write these words out all day and then give you the definition, but you don't know what it means. And so I'm going to show you what it means, and then you're going to have a note space that you can use to fill in your own words that it is. And I'm going to have this will make sense to you when it's done. All right, so we're going to start right here. So what do we mean by two-way frequency table? Let's first start with the word frequency. Frequency means think about the word frequent. How often does something happen? For instance, whenever I'm eating calories after 7 o'clock, Mr. Warren frequently eats after 7 o'clock when he knows he shouldn't. So the frequency in which I eat after 7 is quite too high. So frequency is a count. Now let's look at the word joint. The word joint means shared. It's like joint banking accounts. So shared frequency. Why does that mean the shared count? Joint frequency, shared count. Shared between what? Well, let's talk about the two ways. Look at this table to the right over here. This table to the right is dealing with two major populations. They're divided into age or grade, and then divided into what the question is. So what are we talking about? We polled 6th and 7th graders. So the groups that we're dealing with are 6th graders and 7th graders. The question we asked was, do you prefer dogs or cats? So it's a shared example. It's shared data. It's two ways. What do I mean by that? Going to the right. Let's read this chart to the right. So one way is, I'm looking over here. According to this data, there were 6th graders. 8 of them liked dogs. 4 of them liked cats. How many total 6th graders were there that interviewed? 12. So if you read the table one way from left to right, you can get information about how many 6th graders we had. Now let's go check out with 7th graders, moving from left to right. 6 7th graders liked dogs. 7 7th graders liked cats, for a total of 13 7th graders. Now, I'm going to go the other way, up and down, y'all. Now I'm going to go to the dog column. How many dog lovers total are here? There's 14 total that like dogs. What about cats? There's 11 that prefer their cats over dogs. I want you to see something. 14 plus 11 equals 25. 12 plus 13 equals 25. These totals add up to each other. So it's a total of 25 people. A total of 25 people were interviewed. And then this is how the data is split up. So you basically have two-way frequency tables. You have to be able to two-way frequency. Remember, two-way, left and right, up and down. Frequency, the amount of stuff that takes place. So that's basically how this works right here. And so let's go ahead and talk about it. The first thing I'm going to do, all I'm going to say about joint frequency is it's always going to be a number. It's not a percent. It's always a number. I'm going to talk about relative frequency. Relative frequency, you're going to be seeing this over and over. It is always going to be a percent. It is always going to be a percent. You need the percentage formula. The percentage formula looks like this. And yes, y'all hear me rant about this stuff all the time, no exception. This is something you're supposed to know. By freshman year, you are supposed to be able to do percentages in your sleep. I don't know what's happened to our society that y'all can't, but here we are. So how this works is part divided by whole times 100. What do I mean by that? Well, let's take a small example real quick. Let's say I had a pizza that was divided into, let's do 6 slices. Oh, that's a scary looking slice. We're going to do this. 6 slices total. Look at that. It's still ugly. Whatever. So what do I mean by that? You see the 6 slices? How many total slices are there? There's 6. Let's say Mr. Warren was feeling a little extra hungry that day, and he went through and had 3 slices. He had 3 slices right there. 3 out of 6. That is what we mean by part divided by a whole. The total number of pizza slices we started with was 6. Mr. Warren's fat butt ate 3 of those pieces right there. And so if you were to do this on Desmos, what would the percentage of pizza I ate? Well, let's just look at it visually. Obviously, I ate half. Obviously, I ate half the pizza. So what is half in terms of percentage? 50%. 50%. Let's see if our math works out. Let's go to Desmos and see. 3, that's the pieces I ate. Total out of 6. Let's go eat this. Do this on Desmos. It's like, now I'm talking about food again. Y'all know I talk about food way too much. So I'm going to do this formula in there. Remember, visually, we saw that Mr. Warren's fat butt ate half that pizza. But the math works out, check it out, y'all, 50. When you multiply by 100, you end up with 50%. So when you do this work, you're going to end up with writing it like this. 50%. You have to have the percent or it's not a percent, it's just a number. 50%. Joint frequency will always be a number. Relative frequency is always going to be a percent. So let's go ahead and start this work together. Let's go ahead and look at number 1. What is the joint frequency of 6th graders who like dogs? 6th graders who like dogs. What's the number? What's the shared counts between them? Between the sharing column of dogs and 6th graders, what's the amount, the frequency? 8. Relative frequency. Remember, y'all, it is a percentage. So this A is referring to this A right here. So what is the relative frequency for A, in this case, 6th graders who like dogs, compared to total dog lovers? Compared to total dog lovers. Let's look at this. How many dog lovers do we have? There's a category of dogs. Go down to the very bottom. What's the total number or the whole that we're dealing with? 14. 14. And then our data in A, 6th graders who like dogs. We have 8. So they want the relative frequency for A compared to total dog lovers. Compared to total dog lovers. So the relative frequency is a percentage. We're going to go over here and we're going to type this into Desmos. 8 divided by 14. 8 divided by 14 times 100. Check it out. It's not an exact number. We don't care. We're going to round to 2 decimal places at first. 57.14. So here's what we have to do, y'all. You have to learn this symbol right here. See how it kind of looks like a wavy's equal sign? That's the approximate. It's a little, not quite as wavy as that, but it's a little bit a wavy equal sign. That means approximation. 57.1, what was it? It was 57.14. So this comes out to 57.14%, but I'm going to have y'all round this time to the ones place. So when we round it, again, it's about equal to 57%. 57%. These are just normal rounding rules. So this is less than 5. It's going to be right here. This one is less than 5, so we round to 57. So the total comes out, or the relative frequency comes out to 57% for that problem. I'm going to clear all this mess here. There's not tons of space. So then I'm going to work on B. So if you need to see A again, rewind it. Here we go. We're going to go to B. Now, on B, I'm going to scroll down a bit. On B, it's asking me the joint frequency, the count between 7th graders who like cats. So find our shared information. We are sharing between cats and 7th graders. The joint information here. So how many 7th graders like cats? 7. What is the relative frequency of that compared to total cat lovers? Total cat lovers. How many cat lovers do we have? We have 11. So the total that we have, the whole, is 11, and the part of it is 7. So when we're all said and done, we're going to create the percentage of that. Let's go over here and check our Desmos, and we get 7 divided by 11. 7 divided by 11 right here ends up giving us 63.64%. I'm going to round up, 63.64%. But I don't want those decimals on this assignment. And if you aren't given instructions on what to do, look at my mistake. Approximately. We're going to do approximate. We're going to round up. This time this number is above 5 and above, so it's going to be 64%. 64%. So that becomes your answer for that one right there. Now we're going to go ahead and I'm going to clear this and I'm going to go to C. 7th graders who like dogs. 7th graders who like dogs. 7th graders who like dogs, 6. Now compare it to total 7th graders. Total 7th graders. Find the column. Total 7th graders is 13. So our fraction we're getting now is 6 out of 13 times 100. So let's go to, that's my little wavy equal sign, the approximation sign. 6 divided by 13. 6 divided by 13 times 100 gives us 46.15%. 46.15%. 46.15%. And I want to go even further than that. Again, keep the wavy sign. There is a problem out here that comes out exactly. If you come out to exact, you got to use that equal sign. If you're rounding, I want you to use this little sucker right there. So this comes out to 46% because we're rounding down. Normal rules of rounding. Relative frequency, y'all. I think this is pretty straightforward. I'm going to let y'all figure out D on yourself because I don't want to keep working these. I want to go to E, F, and G. Now let's look at the wording on E, F, G. What is the percentage of all students? How many students did we interview? All students? Y'all, we interviewed 25. All students that prefer cats. So what's the total amount of cat lovers over here? We have 11. So do you see how it's still the relative frequency, but we can ask what's the percentage? Do you see that? So there's different ways to ask these questions. I think the wording is the most tricky part about this problem. So here we go. We found our population of all students is 25. The total cat lovers is 11. So I'm not going to do this work for you anymore. I'm just going to set it up. And then you're going to have this. So go ahead and, I think this is the one that comes out exact, if I'm not mistaken. Right there, 1 second. And now we are back to F. So percentage of sixth graders. Hold on, I'm on the video. Hang on. Okay, sorry, I'm doing this in my freshman academy. It's Fun Friday, and I realize I need to do a better video. Okay, so here we are. Now we are in percentage of sixth graders that prefer dogs. Sixth graders that prefer dogs. Now notice this wording. This wording isn't exact. Is this compared to total sixth graders, or is this compared to total population? I compared it to total population, but if you read this wording carefully, it's technically implying to imply it, do it towards all sixth graders. So depending on the wording and depending on how your brain works, you could write this as percentage of sixth graders that prefer dogs. All sixth graders that prefer dogs. How many sixth graders do we have? 12. How many of them prefer dogs? 8. But if you read this as percentage of sixth graders compared to the total population, then the sixth graders who like dogs is 8, and then the total population is 25. Now, why do I have these examples in here? Because the wording matters, y'all. If you don't understand the wording of a problem, and you're not if it's not concise enough, then you need to come up there and either ask me, or you need to back up your work when you say, well, this is how I read the problem. So you see how in D it's concise compared to total sixth graders. Sometimes the words aren't. So when you're on the test and you're confused what it's asking, ask for help, because that is the nature of data. One word can change the entire data set. So if you would have set it up this way or this way, the way this problem is worded, I would give you either credit. I interpreted this both ways, either comparing it to only sixth graders or comparing it to all population. So up to you how you see this. Same thing with G, percentage of seventh graders. This in my mind is like total seventh graders, right? Total seventh graders is 13. And then the seventh graders that actually likes cats is 7. But if your brain works where it's like, this isn't exact enough for you, and again, that's a real thing, and you compared it to the entire population, then your work would look like this. The amount of seventh graders that likes cats is 7, and then the total population is 25. Which one is more correct? Probably this one. But can you make a case for the other one? Yes. So remember, sometimes the wording in real life is ambiguous, and you have to get clarification. So that's it. That's the essentials for this assignment right here. I'm going to push pause and do another little activity. All right. I paused and loaded up the other assignment. I'm not going to help you do these other assignments. You have to do this yourself. What I'm going to show you is how to fill out the rest of the table. Look what you notice. There's addition and subtraction, y'all. I'm going to go ahead and just fill this out, and I think it explains itself. This is saying, what's this number here? We'll look at it. The total is 35. The boys that prefer Nikes is at 22. So what number does this have to be? Well, do some subtraction. 35 minus 22 is 13. 22 plus 13 is 35. So now let's go over here and check it out. 11 plus 19 is 30. 35 plus 30 gives us 65. Look up here, up and down. Let's add this. 22 plus 11 gives me 33. 13 plus 19 gives me 32. Check your work. Does 33 plus 32 equal 65? Yep. Is 35 plus 30 equals 65? Yep, you did it. So the rest of these questions you can do on your own, but I am going to take you to this part here. You'll notice here, look what's missing. You have to add this yourself. Sometimes these data tables are incomplete, and you need to add this yourself. So add this total here yourself. Boom and boom. Look over here, boom and boom. And boom and boom, and boom and boom. And then I'm going to go through here, green for given. This is going to be totals. This is going to be total. Now let's do this carefully together. Let's read this problem together. 50 students were polled. That's the total amount of students polled. The total number polled was 50. Look how easy that was. Now, 26 students like shopping. See the like shoppings? 26 total students like shopping. Goes here. 37 students have an iPhone. Look at this, have an iPhone. 37 students total have an iPhone. 37 goes here. 23 students have an iPhone but don't like shopping. Don't like shopping right here, doesn't like shopping, and they have an iPhone. 23. That's the data given to us. Now, how do we find the rest of the data ourselves? Addition and subtraction. 37 minus 23 gives me 14. 26 minus 14 gives me 12. A student made a comparison to Sudoku, kind of a little bit. You're just filling these missing pieces in with addition and subtraction. Sudoku more is about repeating stuff, but you're filling in stuff. 50 minus 37 is 13. 13 minus 12 is 1. 23 plus 1 is 24. Check your work. Does 26 plus 24 equal 50? Yes, it does. 37 plus 13 equal 50? Yes, it does. So now on number 2, you'll have to fill in your own totals here. Got it? That's the videos for this stuff. Good luck.